Hi everyone, we are going to continue today chapter 3 section 4, which is about everyday forces. In this section we are going to learn describe some forces: gravitational force, normal force, and study again kinetic friction forces and their effects on the motion of an object. First force I'm going to talk about is the gravitational force and weight. So the force exerted on an object by a planet or by a space object is called gravitational force and represented by G. So every object on the surface of a planet or in the influence of a planet will be attracted by that planet. So this force, attractive force, is called gravitational force and represented by Fg. This force, just like every force, is also a vector quantity, so it has also direction, and the force which is acting on the object by a planet or by any space object, it can be a moon, it can be a star as well, always will be directed towards the center of the planet, center of the earth. For example, if I drop a ball in air, this ball has a mass m, and we know that if you drop this ball will accelerate with the acceleration which is equal to free fall acceleration g. And if there's an acceleration according to Newton's second law, there must be a force, a net force acting on this object, and this net force must be in the same direction of the acceleration. That means the force, net force acting on this object will be downward. That net force is what the force which we are talking about. So that force is going to be gravitational force, and it will be acting downward, and we are going to draw it from the center of the ball. So according to Newton's second law, which is equal to m, F net is equal to m times acceleration. Because the only acceleration for this ball is the free fall acceleration, so the force, the net force acting on this object is going to be the gravitational force Fg, if we neglect air resistance, of course. So that's why we are going to draw this force acting on this ball from the center of this ball downward towards the center of the earth, and it will be indicated by Fg is equal to mass times free fall acceleration. And its magnitude, the magnitude of this gravitational force is called weight. So weight, in fact, it's how much the strength of this the gravitational force. So weight indicates that. That's why equation for weight is going to be without arrows. Fg is equal to m times g, mass of the object, multiplied by free fall acceleration of that planet. And this, as you see, gravitational force or weight depends on two things. One of them is the mass of the object. Second one is the free fall acceleration of the planet. Because mass of an object is constant, it depends on the number of molecules. So because number of molecules of a specific object will not change, so mass of an object does not change. Even you take the object from Earth to the moon, or from moon to the Jupiter, or from Jupiter to some other place, mass does not change. But because G is different for every different planet, so when you take an object from Earth to the moon, so its weight will change, or from moon to the Jupiter, or from Jupiter to Mercury. So whenever you change the planet of an object, because free fall acceleration for every object is different, weight all will change. And weight changes with gravity, weight changes with G. So unlike mass, it depends on location. Mass does not depend on the location, but weight depends on location. Because the gravity for each planet, gravity and G for each planet is different, weight and object is measured different on different planets, different space bodies. Even on the Earth, objects' weight may vary with location, because gravity of a planet is changing as altitude from the center, distance from the center is changing. So in here, we have a less gravity, greater gravity is in compared to the top of a mountain. And G2, which is the gravitational acceleration at the top of a mountain, always will be less than G1, which is at the bottom of the mountain. That's why on the earth, when you are going up to the sky, when you are rising, when you are climbing a mountain, So because g is decreasing, weight of the object also decreases. So then we say that even on the Earth, object's weight may vary with location. Object's weight is less at higher altitudes than they do at sea level. At sea level, let's say G1, at higher altitudes, G2. So G2 is less than G1. That's why FG2, gravitational force to weight, which is weight, less than FG1, yani weight at the top of the mountain will be less than the weight at sea level. And even about this 11th grade title, there's Mr. Exam questions asking Mr. in the 12th grade. This is very popular question. It's asked which of the following statement is correct. A, mass and weight both vary with location. We know that mass doesn't change. Mass doesn't change. Does not change. But weight changes. So that's why this statement is incorrect. Mass varies with location, but weight does not. No, vice versa. Mass does not change, weight does. Weight varies with location, but mass does not. So this is the correct answer. Neither mass nor weight varies with location. So C is the correct answer in here. Now we'll continue with another everyday force, which is the normal force. Normal as a word has a meaning that which is a line perpendicular to a surface. Maybe you remember in the when you were studying the law of reflections in the 10th grade, you draw a line which is perpendicular to the surface, and you set that line as normal of the surface, and you apply the reflection law. Incoming light makes the same angle with the reflected ray. Any line perpendicular to a surface, it's called normal of that surface. So a normal force is perpendicular force in this case, but perpendicular to what? So we will learn about this one now. Imagine a television set at rest on a table. So this is the TV, this is the table. So you put the television on a table. Let's draw the free body diagram for television. So remember, free body diagram is the forces. We are going to draw the forces acting on an object. So I am going to draw forces acting on TV. So that's why I have to check this TV is in interaction with the environment in how many ways. There are interaction between this television and its environment by two ways. One of them is this television and Earth interact with one another. So this television interacts with Earth. So they attract one another. Earth attracts the television, and television in turn also attracts the Earth. So these are first action-reaction pairs. So action-reaction pairs. So I can hear you say that, teacher, how is it possible the television attracts the Earth? Yes, it does. So remember, we said that in the nature, a single isolated force is not possible. Always forces are created in pairs. So Earth attracts the television also attracts Earth. If you say one of them action, the other one will be reaction force. So this is the first interaction, television and Earth. There is also interaction between television and the table. This is contact force. First one was field force because Earth and television not directly in contact. So this is the field force. Gravitational force is a field force. Field force also created in pairs. So Fg and Fg prime, I represented them action and reaction forces. If you say one of them is action, the other one is reaction. But television is also in contact with the table. So there is a contact force between television and table. So television interacts with the table. So television pushes the table downward with Fn prime, and table reacts television with Fn. And there is also an action-reaction pair between television and table. Television pushes the table down with Fn prime. This is if you say this is the action on the table, so reaction must be on television. Remember, action-reaction forces are always on different objects and acts in opposite direction equal in magnitude. So in this case, you are going to say this is reaction. So second action-reaction pair is Fn and Fn prime action-reaction pair. Reaction pair. And the question was about drawing the free body diagram for television. That's why you are going to isolate television from other objects, and you are going to show only the forces acting on television. So two forces act on television according to this diagram. One of them is the gravitational force by the earth, Fg. Second one is the reaction force by the table. So gravitational force by the earth, remember we said it's the weight, magnitude of that force is called weight. Reaction force by the table we defined is as, so that force is defined as normal force. Reason is what? Because this force, this Fn, always perpendicular to contact surface. Normal means perpendicular Fn. That reaction force by the table will be perpendicular to the contact surface. It's obvious in here, contact surface is in a horizontal, this green line is representing contact surface, and Fn, as you see, in vertical. That's why Fn must be perpendicular to contact surface. So I will write the properties of normal forces first. Always exist between two objects in contact. Yani if you are talking about a normal force, so you should check if the objects are in contact or not. If objects are in contact, then you can talk about normal force. Second one is this force is always perpendicular to contact surface. So contact surface in here is the horizontal. That's why normal force must be in vertical. And if we check the television, we see television is at rest. So being at rest is the condition, first condition of Newton's first law of motion. And sum of the force acting on the television must be equal to 0, so at rest. So remember, if an object is at rest, it will stay at rest. If an object is in motion, it will continue moving with constant velocity. It was the first law of motion, net force acting on the object must be equal to 0. Now let's add them. One force is in positive y direction, Fn, so second force is in negative y direction, which is Fg. So which means sum of these two forces must be equal to each other. Let's clean this arrow sign. So we know they are in opposite directions, but magnitude of these two also must be equal to each other. If you take this negative Fg to the right side, Fn becomes equal to Fg. Normal force acting on an object when the object is on a horizontal surface is equal to gravitational force. Fn is equal to Fg. But one condition is this: object must be on a horizontal surface, so television is on a horizontal surface, and also television must be under the influence of force of gravity. There mustn't be another push or pull. Only gravitational force must pull this object. So in this case, you can say that, yes, normal force is equal to gravitational force. Fn is equal to Fg. But normal force is not always equal to Fg. For example, just like this inclined surface, when the surface is inclined, so normal force by inclined plane will not be equal to always Fg. So, but what is it? How can we calculate normal force applied by an inclined surface on an object on it? So to understand it, of course, we should draw the free body diagram. And I'm going to choose angle of inclination as 30 degrees. So this angle is 30 degrees. First, I have to determine the xy coordinate system, and I have to locate this object, which is on the surface of the inclined plane in this xy coordinate system. While we are drawing a coordinate system, choose the x-axis along the direction of the acceleration. In which direction you predict object to be accelerate, draw x-axis along the acceleration. So this object will accelerate along the surface of the inclined plane. That's why I'm going to draw x-axis parallel to surface of the inclined plane. Y is going to be perpendicular to this surface. So this angle is going to be 90 degrees. In this case, also angle between x and y always 90 degrees. Now I will draw the forces acting on this object. First force is gravitational force. Of course, Earth always pulls the object down in vertical. First force is Fg, gravitational force. But this force, as you see, is inclined according to xy coordinate system. Second force is, of course, this inclined plane must be reacting this object. So this reaction force, remember, we defined as normal force, and this normal force must be along y-axis, because we know that normal force is always perpendicular to contact surface. So this angle is 90 degree. If it is 90 degree, so that's why Fn must be along y-axis. But Fg is inclined according to this xy coordinate system. So to resolve a vector into components, you have to draw lines from the tip of the vector to x and y axis. If you want to calculate the y-axis, so you have to draw a line parallel to x-axis from the tip of the vector, and then from the origin to that point you have to draw an arrow. This arrow is going to be representing y component of Fg, which is along y-axis. To get the x component, you have to draw a line from the tip of the vector to x parallel to y, perpendicular to x. So this line must be drawn. Then from the origin you are going to draw a directional line, which is Fgx. So Fg has two components, Fgy and Fgx. This Fgx, as you see, acting along x-axis, but no other force is acting along x, which means this Fgx causes this object to accelerate, because no other force acts along x-axis. Resultant force along x-axis is equal to Fgx. So Fgx and component along x-axis accelerates the object along the inclined plane. But along y-axis, we see that there are two forces acting on the object. One of them is the Fn normal force in positive y direction. The other one is Fgy, y component of the gravitational force, in the negative y direction. Because object is not accelerating along y-axis, so some of these two forces, yani Fn and Fgy, some of them must be equal to 0. Fn is in positive y direction, Fgy is in negative y direction. So when we add them, result must be equal to 0. This tells you that Fn is equal to Fgy in magnitude. Fn in here is not equal to Fg. Fn in here is equal to y component of Fg. So component along the y-axis, Fgy is equal to normal force, Fn is equal to Fgy. Now I need to calculate its magnitude. How can I calculate y component in terms of Fg? I need to know the angle between the Fg and xy coordinate system. And I need to know this angle or that angle. I have to calculate one of them. After that, I can calculate magnitude of Fgx and Fgy. If you look at in here, you are going to see here exists a right angle triangle. So I will draw with red, then clean this one. This is a right angled triangle. In a right angled triangle, we know that sum of the internal angles is equal to 180 degrees. This is 90, this is 30. That angle is going to be 60 degrees, because 60 plus 30 is equal to 90. Other 90 in here, it's going to be equal to 180. That's why first we should get this angle. This angle is 60 degrees. This angle is 60 degrees. Then I am going to draw one more right angle triangle in here. So here in this right angle triangle, you see that this angle we calculated 60. This is 90. Then that angle is how much? So sum of this angle and 60 must be equal to 90. That's why this angle must be equal to 30. So this is always correct for an object on an inclined plane. That angle, whatever the inclination angle is, so this angle always will be an angle between the gravitational force and y-axis always will be equal to this angle 30 degrees. Then we can calculate FGX and FGY. So according to this right angle triangle in here, you see that. So right angle triangle, FGX is the opposite leg. Length of the opposite leg is equal to FGX. So this is FGX, this is the opposite leg. Opposite leg always calculated by a hypotenuse, which is in here, is equal to FG multiplied by sine of 30. So FG times sine 30 will calculate the FGX x component of FG. But according to this right angle triangle again, so in here, if I want to calculate FGY, which is the adjacent leg of the right angle triangle according to this angle, so adjacent side is calculated by hypotenuse, which is FG multiplied by cosine 30. If I multiply FG by cosine 30, I will calculate the magnitude of the y component of FG. And FG cosine theta is equal to FGY. I can rewrite this equation for any angle. So this angle is going to be theta, and you are going to be calculating always Fn, which is equal to Fg times sine theta. Theta is what in here? The inclination angle. The inclination angle of the surface is theta, so you can easily calculate Fn is equal to Fg times cosine theta. What about Fgx? Fgx is going to be always Fg times sine theta. This Fg times sine theta will accelerate the object along the inclined plane. Fg cosine theta will be the normal force applied by the inclined plane on the object. So this is all about the gravitational force and normal force. In the next lesson, we will continue with the force of static and kinetic frictions.